Well, students, this is part number 2 of foldable number 4, and we're still on dilations. So for this one, we're going to be reflecting over the x-axis. So in order to do that, let me just switch pen colors with this magical pen. We're just going to look at this here, and this is reflecting over the x-axis, and we see here this is the x-axis here, and this is the y-axis here. So we're going to be reflecting over this axis here. So in order to do that, we're going to get our number that we get. So this is our y is equal to x squared. And the number that we get here, we actually have a negative in front. So we're going to change this to negative. So we started, we have negative 3. Went to 9, but now with our negative function, we're going to go to negative 9. So does it even go to 9? Nope, it goes to... No, we're just going to make it go to 9. So 1, 2, 3. This goes to 8. And then we're going to give it one little point there to go to 9. Then we're going to go negative 2. Negative 2 went 4, but we're going to multiply it by negative. So it goes negative 2 goes to negative 4. 1, 2, 3, 4. Our negative 1 now goes to negative 1. 0 goes to 0. 1 times negative 1 goes to negative 1. 2 goes to negative 4. Positive 2, negative 4, and 3 goes to negative 9, which is about right there as well. So we're going to go ahead and draw this here. Sort of kind of connect the other graph on the bottom, but as you can see, this is a reflection. So all these points correlate to the points on the original parent graph. And if we were to fold this over on itself, it would actually match up. These two graphs would match up perfectly here. Boom. Okay. So that was our reflection over the x-axis. Now we're going to go ahead and do the reflection over the y-axis. Similar to the other one, we're going to be reflecting over one of the axes. So this is the y and this is the x. The one above us, we reflected over the x. Now we're going to reflect over the y. So in order to do that, we're going to take this here. But if you notice that, once again, like we did on the absolute value, we have our y is equal to x squared. And then here we have our y is equal to negative x squared. But anything negative, that's going to be squared because negative times a negative is a positive. So we're going to have the same result here. So our graph is going to be identical again to the one we had before. But we're going to go ahead and do that. So negative 3, 9. Negative 2 and 4. Negative 1 and 1. 0 and 0. 1 and 1. 2 and 4, and 3 and 9. And I'm going to do this one in highlighter again so you guys can see what it looks like. Try to be careful because it's not just a line, it's a parabola. So it's going to be reflected on itself. And if you see, we can see this by folding the graph over there. You would actually, this part would fall on top of this part. So these points have to be equidistant to the y-axis because we're going to flip it over. So we're going to count. We have 1 and then 1 to get there. Perfect. 1, 2 to get to the y. And then 1, 2 to get there. Perfect. And this one would be 1, 2, 3 to get to the y. And then 1, 2, 3 to get there. So it's perfect.